Now, let me give you a tip on how you can streamline and simplify trigonometric expressions easier than ever before. And here's the tip. Recognize that, you know, the algebra we do with real numbers where we cancel top and bottom, where we divide, where we factor, where we get lowest common denominators, all those processes are exactly the same when we're working with trigonometric identities or trig expressions. They're exactly the same, but the good news with trig expression is not only can you cancel top and bottom, add, subtract, factor, all those processes exactly the same, but you can also modify, alter, and transform them from one form to another. And I've got them all down here. For example, cosec theta equals 1 over sine theta, or cot theta, cotangent equals cos on sine. So you can transform them and change them and manipulate them in such a way that you can achieve your outcome of simplifying. We have an example up here. We have a trigonometric expression. It's 1 over 1 plus sine theta plus 1 over 1 minus sine theta. So what we're asked to do is to simplify this expression. So let's get stuck into it and start simplifying. Now, the first thing you're going to recognize is we have denominators here. So we're going to add these two guys just like normal, conventional, ordinary fractions. So let's get ourselves a lowest common denominator. So let me just put the line across here. So the lowest common denominator, I like to just multiply these two guys that we have here as denominators already. So I'll put it down as 1 plus sine theta in brackets and drag this down here just like that. Okay, let me close brackets over there. Okay, so let's drag this into here. Let's divide the denominator into this part and it'll yield this part. So up here we have 1 minus, drag the plus down here. And over here, let's divide 1 minus sine theta into the denominator. We're left with this. So we multiply this up here. So it's just like normal fractions. Or if you wish, you can cross multiply. You can multiply that times that and it'll give you that. And that times that will give you that. But only when you multiply the denominator. So that's another way to do fractions. I'm sure you've got your way of doing it. So let's simplify the numerator, the top over there. Well, we have two 1s over here, don't we? So we can add them together. So on the top, we have a 2, and we have a minus sine theta and a plus sine theta. So it's true that they're going to cancel. So minus sine theta cancel, plus sine theta cancel. So we're left on the numerator on the top with just 2. Let's look at the denominator down here. We can expand this just like with normal real numbers. So it's, you know, you can use the FOIL method. 1 times 1 is 1. Minus sine theta plus sine theta, well, they're going to cancel, leaving sine theta times negative sine theta, which is minus sine theta. And of course, it's squared, minus sine theta squared. Okay, so now we've got 2 over 1 minus sine squared theta. So this kind of looks like one of those Pythagorean identities where we have, you might recall, sine squared theta plus cos squared theta equals 1. And we know that 1 minus sine, so we drag this sine on this side, therefore equals 1 minus sine squared theta. So we can replace 1 minus sine squared theta here with cosine squared theta, can't we? So this will equal over here 2 over cosine squared theta. So that's simplified. We can go even further because we have over here something like this. We have 2 over 1 times 1 over cosine squared theta. Now 1 over cosine squared theta, that's going to have a reciprocal when we flip it. And which one over here down here in yellow? 1 on cosine. 1 on cosine is right over here, as you can see. That's secant, right over there. That's a secant. So we can replace that with secant. So that means our answer will be 2 secant squared theta. Okay, that is simplified. How about we try another example? Here's one over here. This one's a little different. You have on the top, on the numerator, tan theta over secant theta on the denominator. So how we're going to simplify this? Well, all we have to do is use what we have down here, reciprocal functions. So what have we got? On the top we got tan, so we could kind of write it out like this. We've got tan theta, which essentially is the same as sine theta on cosine theta. Isn't it true? So where's our tan theta? Here we go here. Tan theta equals sine over cos. So there we have it. And we're dividing by secant theta. Now what's secant theta? What's secant? Well, secant theta is the same as, let's go down here again. Secant theta is the same as 1 on cosine, isn't it? We can see it right there, 1 on cosine. So if it's 1 on cosine, well then all we have to do is simply divide by 1 on cosine. So let me just put a black line here. Divide by. So we're dividing a fraction by another fraction because it's the bottom divided into the top. So if we write this out with conventional algebra, you know, when you divide by a fraction, you turn it upside down, you flip it, and then you multiply by it, which is the same. So that's going to mean we got times cosine theta over 1. So that part goes here. We drag and drop that down here. So now we just can cancel, can't we? Just like with normal algebra. So we cancel the cosines, top and bottom. Cancel on the top, cancel on the bottom. We're left the grand total. The answer is this simplified